Hi class, and welcome to your fifth lesson. All right, this lesson here is over inequalities. So you should have your R5 notes in front of you, ready to go. It's a little bit longer, so I apologize, but this way you can get it done in one instead of two sittings. If you need to pause it in the middle, that's fine. Let's see if we can get this moving. All right, when you're looking at your R5 inequalities, you're going through here. There's four things we're going to do today. So we're going to solve linear inequalities, so lines. We are going to solve quadratics. Remember, your quadratics are your parabolas. Any polynomial inequality, so it can have, and then rational inequalities. So this can be anything, any like cubes, fourths, whatever we want. Rational just means it's in a fractional form. First thing I want to go over is some of the old notation versus new notation. And you should have learned this last year, so it should just be a review. So remember, your parentheses are your open. They used to be open circles when you were younger, but now they're going to be, now you're going to see parentheses instead on your number line. So when X is between A and B, so when you're on a number line, so whatever A could be 5 and B could be 127, it doesn't matter. When it says less than, so X actually reading this direction is greater than A, but that's a parenthesis because that means it cannot be equal to A, and it also has to be less than B, which is also a parenthesis because it cannot be equal to B. Remember, your equal to signs are just your brackets. So that means it can equal A, whatever the value of A is and whatever the value of B is. So that's when we use the brackets. So that means it can equal that number up to and equal to that number. Greater than, perhaps remember infinity, that's just your straight arrow. So you have your number on your number line. It cannot equal A because there's no equal sign with the thing. That was weird. So we have a parenthesis here with our arrow going this way, indicating it goes on forever on the number line. And now we have B where it's equal to. So remember, your equal to is your bracket. And this one was less than, so it goes this way on the number line forever. So linear inequalities just means you have one answer. So when you're going through here, you must solve it first and then graph. So however you want to do it, you can either subtract the 3 or the 5x, it doesn't matter. I'm going to do the 3x just for fun. So minus 3x on both sides. Well, if I move the x's this way, that means I have to move the numbers this way. So I'm going to subtract the 7. I'm doing it all in one step just to make my life a little easier. So the 7's cancel here. The 3x's cancel here. I now have a negative 9 is greater than 2x. I have to get the x alone, so I have to divide. So I got a negative 9 halves. Let's move over. Is greater than x. That always bothers me. I always think it looks funny. So I'm going to write x is less than a negative 9 halves, just so that I can see it in the right direction. So on the number line, all I really care is you have the negative 9 halves because that's the point I care about. Less than means it's a parenthesis and it's going this direction. Whoops, I missed my bracket. Oh well, pretend that's right there. And it goes on forever. Nothing too difficult and nothing should be new. All right, now I would like you to try this one on your own and then pause it. Or pause it and try it on and try what you did. So we have a plus 1, but now I got two inequalities, which means I have to do it on both sides. So that means I have to subtract the 1 from the 8 and the 13. I hope you did all three. So you got 7 is less than or equal to, so remember that's going to be a bracket, 3x, which is less than 12. Since that's a less than, it will be a parenthesis. Divide by your 3. I'm going to move over because I ran out of room. So I have 7/3 is less than or equal to x, which is less than 4. So in my number line, I will need the 4. I will need the 7/3. I know x is reading this way, greater than 7/3 or equal to, so it's a bracket. It is less than 4, so it is a parenthesis, and inclusive of all those numbers in between. I'm hoping you remember set builder notation, which is the parenthesis, x, remember your line, such that, and then we have 7/3 is less than or equal to x is less than 4. So if they ask for set builder, that is what they're asking for. All right, now let's look at this x squared minus x plus 12. So now we're into quadratics because we've got that x squared there. So in order to solve that, do you remember what to do? I'm hoping so. You got to set it equal to 0, right? So we're going to take and move this 12 over. So we have x squared minus x minus 12 is less than 0. So in other words, this means it is negative, is what we're looking for. Oh, I put 4 instead of 12. What am I thinking? Here, let's get rid of this and make that look a little prettier. Not good when we already got a long lesson, huh? Okay, so we got minus 12. Now, factors of 12 that give you 1, and you're subtracting, so you know that's 4 and 3. So it's x minus 4, because I need the negative 1. X plus 3 is to be less than 0. Now, this has to be negative here. So I know my critical points are where you set these equal to 0. So that's going to be x equal 4 and x equal negative 3. So on my number line, I'm going to have negative 3 and I'm going to have 4. I want to know these in-between parts here, if those are true or false. So where does my graph go? When you're looking at this, I know I want it to be negative. I have 2 things to multiply, so one of them has to be negative, or it's going to be a positive answer. So let's pick some numbers in between here and see if we can figure this out. So negative 3, I need to pick numbers in this section here. So I'm going to pick a negative 4. In this section, I'm going to pick 0. And in this section, I'm going to pick 5. Well, you can pick any numbers in there you want. I just chose some. We're going to plug these numbers into this equation and see if I get a negative number. So I'm not actually going to do all that math because that takes too long. So I'm going to plug my negative 4 in for my x. So I got a negative 4 minus 4 times negative 4 plus 3. Well, this is a negative number, and this is a negative. A negative times a negative is absolutely a positive, but I need a negative answer because it's less than 0. So this one does not work. So now let's plug in the 0. Let's choose colors here. 0 again up here. So we get 0 minus 4. And then we have 0 plus 3. All right, and minus 4, so that one's negative. This is positive. A negative times a positive is a negative. Oh, awesome. So this section works. Now I got to check my last section. Excuse me. Let's plug in our 5. So now we have 5 minus 4 and 5 plus 3. Well, 5 minus 4, that's positive, and that's positive. Positive times a positive is a positive, but I need a negative, so that guy's wrong. So my answer is between negative 3 and 4. These are the numbers that solve that inequality. All right, I just want you to look at this for a little bit so you understand what it actually means. If I was graphing it, so let's go back to last year. Here's our XY system. We're going to put a negative 3 here and a 4 here. You know it's a parabola, it's positive, so you know that that is facing up. I'm hoping you remember how to find your vertex. So you know the x value of vertex is equal to opposite of b over 2a, just in case you forgot. Well, the opposite of b is that negative 1, so that's opposite of that is 1 over 2, and a is 1. So my vertex is at 1/2, so I know at 1/2, so right here somewhere, is the x value. I have to plug that in to find the y value. So I'm going to take 1/2 into my original equation. That's where we're going. So you're up here. That's where you're looking. 1/2 minus, or squared, minus 1/2 minus 12. All right, when I do that, so that's 1/4 minus 1/2, which gives me a 4. So I got a negative 12 and a 4th. It's my vertex. I'm just going to make a dot. And we're going to pretend. So that's negative 12 and a 4th. This parabola, now it's a less than. So I know it is a dashed line. Okay, and this is where it's good, which means it shades on the inside of that parabola. So that's what you're really doing. Even though your homework won't answer you for that, it should help you understand what you're looking at. Those are the values that make that equation true. Okay, your turn. I do not need the entire the graph parabola. I just want the equation. Go. All right, I'm hoping you looked at this and you had negative 8. Factors of negative 8 that give you 7. Well, that would be a positive 8 and a negative 1. All right, we're going to bring down the 2x squared. We're going to bring down the negative 4. Now we need to factor this, and we put a plus sign in there so we don't forget our negatives. Take out your 2x, which gives you x plus 4. This guy has a negative 1 is all in common, which is x plus 4. So now we have x plus 4 and 2x minus 1. I know that has to be greater than 0, so that means I'm looking for positive solutions now. So my critical points, set these equal to 0. It's going to be negative 4. Then x equals, add your 1 and divide by 2, 1/2. So on my number line, I have 1/2. Oh, did not write that correctly. You're going to run out of room, so we're going to put it over, flip it 4. All right, let's put the negative 4 here. And we're going to put the 1/2 over here. Now we got to check numbers on all sections to see where this is true. So I'm going to choose, let's do 0. I'll do a -5 and a +1. Those shouldn't be too bad to look at. So now when we plug these in, we're going to see if -5, when we plug it in, gives us a positive number. So when we look at -5, I am running out of room to work. We're going to go up here. So I'm just going to move this guy down here. This is where I'm going to work. So I'm going to take -5 right here. -5 plus 4 times 2 times a -5 minus 1. All right, does this equal positive? Well, a negative in this, so this is negative. This is negative 11 is a negative. A negative times a negative is a positive. Ooh, this is nice. So that guy checks. This is a section that works. So now let's look at our 0 and see if I get a negative number there also, or positive. So we're going to plug in 0. So we're going to take 0 plus 4. We're going to take 2 times 0, which is just 0 minus 1. So I got a positive times a negative, which is a negative, but I needed a positive, so this one does not work. So by now you should say, hey, the 1's probably going to work, but we still need to check. So we're going to plug in the 1. So 1 plus 4. You're back to this equation again. Don't forget, that's where you're always going back. 1 plus 4 times 2 times 1, which is 2 minus 1. So this is a positive times a positive, which is a positive. So this y checks. So my answer, since this is greater than, is going to go this way and this way, and it's going to include this. So you should notice that it is an OR graph and not an AND graph. And you should have known that by the greater than sign. It would have told you that. All right, next we're going to do polynomials of lots of variables. That just means you're going to have more than 2 answers. So this one here, I gave you a hint. I said, factor out this. So I want you to pause it, give it a shot. First step is you should have taken out an x. Well, because they all had an x in common, which gave you x squared plus 2x minus 3. All right, factors of 3, that give you 2. And I need a positive 2, so that's a positive 3 and a negative 1. And don't forget your x out here. Okay, this has to be greater than 0, so I know this has to be positive is what I need. Okay, my critical points. I have to set this equal to 0, so this is one of them. X equals 0. Setting this equal to 0, we get negative 3. Setting this one equal to 0, we have 1. So on our number line, we must check negative 3, 0, and 1. And again, it's a greater than, so we know it's going to be parentheses no matter what it is. The numbers we need to choose are just in these areas, so let's choose negative 4. How about negative 1, 1/2, and 2. Again, it doesn't matter what you pick. You can plug them in. So we know we're looking for a positive number here. So let's see what we get when we plug in negative 4. And we're plugging it into this section. So we're going to take a negative 4. Negative 4 plus 3 is a negative 1. I don't have much room, so we're going to do this in our head here. Negative 4 minus 5 is negative 5. Okay, so a negative times a negative times a negative is a negative answer, but I needed a positive, so this section does not work. So let's try this negative 1. Okay, negative 1, of course, is just a negative 1. Negative 1 plus 3 is a positive 2. Negative 1 minus 1 is a negative 2. So a negative times a negative is a positive, which is what I need. So this is a good section. Okay, now let's plug in a 1/2. So we're going to have 1/2 to start it with. 1/2 plus 3 is 3.5. So another positive number. 1/2 minus 1, that's going to be negative number. That's a negative 1/2. A positive times a positive times a negative is a negative. Oh, bad, I need a positive. All right, so now let's plug in the 2. So again, onto that same thing. So we're going to take 2. 2 plus 3 is 5. 2 minus 1 is 1. We got a positive times a positive times a positive, which is a positive, which is the answer I need. So this section works. So your number line looks like, this is a little bit confusing. Let's go down here. We're going to have -3 to 0 is where this one's good. And then it's going to go from 1 to infinity is where that graph is good. Now this is a cube graph, and I know you probably don't remember how to graph all those, but we're going to do a quick sketch anyway. So you should remember that a cube graph, positive ends positive, so it looks like that. These are the 3 roots where it crosses the x-axis. So we have -3, we have a 0, and we have a 1. It starts down, ends high. So we don't know these points here right now, but that's all right. So we're going to go -3 through 0, down 1. Oh, I should have made that. This is dashed. I don't think I can do that on this program. Oh well, pretend that's dashed for me. Okay, and I know it's good from -3 to 0, so this section is good, which makes sense. Then this section is good. So it's like the bottom of the curve that works. All right, let's continue on. I hope you're having fun. Remember, if you have questions, to post them on the discussion board. Okay, your rational inequalities are division. So, whoops, I went too far. So when you look at your division, the first thing you got to do is you got to set the denominator equal to 0, because remember, you cannot divide by 0, so that will always be a critical point. So in this one, we just take the x because that's the denominator and set it equal to 0, so that is 1 point that cannot be on my graph. Since that cannot be on my graph, that is going to be a parenthesis wherever it may be. So the first thing we're going to put on our number line is our 0, because we know that that one is bad. Well, cannot be. It's a critical point. Now we got to solve this. So to solve a rational thing, you just multiply by the denominator. So to get rid of this x here, I'm going to multiply both sides by x. So this guy cancels. So now I'm going to move down here. We have 2x minus 3 is greater than or equal to x. All right, I need to solve this, so I need to get the x's alone. I could subtract the 2x, but that gives me a negative. So, well, we might do that anyway, just to remember how to do it. So subtract the 2x. So you have -3 is greater than or equal to a negative x. Well, this means I have to divide by a -1. Remember, when you divide by a negative, you must switch that inequality. So now you have 3 is less than or equal to x. Rewrite this in the right order. So now x is greater than or equal to 3, which doesn't help us a whole lot, but it does a little bit. So now I have 0 and 3 are my critical points. So now that I have 0 and 3, we have to sit here and check all those points again to see which ones are true and which ones are false. So we're going to go through, and you actually have to plug them back into the original problem to see what works and doesn't work. So we're going to plug in, let's see, what should we pick? Let's do -1, how about 1 and 4? Those don't look too bad. And we're plugging them in here. So you're actually taking 2 times the -1, remember you're up here, minus the 3, all over -1. And I want to know if that's greater than or equal to 1. Well, -2 minus 3, that's -5. -5 over -1, is 5. Well, 5 is definitely greater than 1, so this part checks. So that part works. So now we have to do the 1. Let's do this again. So now we're plugging it into our original equation again. So we're going to plug in 1 up here. So I'm going to take 2 times 1 minus 3 all over 1. So 2 minus 3, that's a -1. -1 divided by 1 is -1. Is -1 greater than or equal to 1? Well, that's absolutely not true. So this section does not work. So now we're going to plug in the 4 and do the same thing again. So 2 times 4 minus 3 divided by 4, is that greater than or equal to 1? So 8 minus 3 is 5. 5/4 positive is, definitely greater than or equal to 1, so this section works. So your final graph will look like, let's draw it over here. You have -1. Since it is a greater than or equal to, we know that this and x cannot be equal to 0. Oh, I drew that wrong. Sorry. Come on, cooperate with me. There we go. All right, so we have 0 is my critical point, and we have 3 is my critical point. It cannot be equal to 0, so we know this is a parenthesis. We know this section works, so this is a parenthesis to infinity. 3 does work, but it can't equal 3 because there's an equal sign here. So that is a bracket with infinity going this direction. All right, pause and try yours. I will get better at this program. All right, when you're looking at yours, first thing you should have done is set the denominator equal to 0. So we know x cannot be equal to 0. Okay, now when you solve this, when you multiplied by the x, it made it kind of nice because that just canceled out. So you have x minus 1 and x plus 1 to be less than 0. So we know our other critical points are 1 and -1. So far your number line looks like so. You have 0, you have a -1, and a 1. Now you have to check all of these sections to see which one holds and doesn't hold. So let's see which we pick. Let's do a -2, a -1/2, a +1/2, and a +2. They don't look too bad. All right, so if we are up here to your original again is where you have to plug those in. So let's plug in the -2. So we take -2 minus 1. We have -2 plus 1 all over -2. So now we have 1, -1. Well, 1 times -1 is -1. -1 divided by -2. And less than 0 means it has to be negative. So I have -1 over -2 is a positive number. Uh-oh. Please don't do this. Okay, there we go. So that does not work. All right, let's check the next one. Let's plug in a -1/2. So we're going to plug in a -1/2 minus 1, a -1/2 plus 1 all over a -1/2. So when we do this, this is a negative number. This is a positive number. A negative divided by a negative is a positive. So that does not work. Where did my... Where'd my recording go? Something is wrong here. Sorry guys, my recording is doing something weird. We may have to finish this on a second one yet. Okay, I got my program to work again, and I'm hoping you caught my mistake here. I was too worried about what was going on. There should have been a -2 right here. So when you look at this, this was a -2. Okay, hopefully it's working again. So this actually should have been a -3. So when you take a negative times a negative, that's a positive. Positive divided by a negative is a negative, so this section is good. Okay, when you plugged in your -1/2, that was a positive, so that section did not work. Okay, now when you plug in your +1/2, so now you've got the 1/2 minus 1 times the 1/2 plus 1, all over the 1/2. So we have a negative number here, a positive number here, and a positive here. So negative divided by a positive is a negative, so this section does work again. Now let's plug in your 2. So we have a 2 minus 1 and a 2 plus 1 all over the 2. So this is a positive and a positive and a positive, giving us a positive number, so this section does not work. So overall, your final number line should be -1, 0, 1. It is good from -1, and everything is parentheses because there's no equal sign. And then it's good between 0 and 1. I hope you did well. Sorry about the long recording. Good luck on your homework. Talk to you later. Bye.